What's up, guys? It's Dan from Sage Math Tutoring. I have a student in a fairly advanced trigonometry class, and I want to make a quick video highlighting some rather advanced trigonometric equations and how to solve them. So let's get right to it. Starting with something like tan of 3 theta equals radical 3. So basically, the tan of some angle equals radical 3. This is where u-substitution can really help, where u would be 3 theta in this case. And then you could rewrite the whole thing as tan u equals radical 3. And from that point forward, you could just sort of treat this as a normal situation. So the question is, the tan of what angle or angles equals radical 3? Well, if you refer to the unit circle, some teachers emphasize using the unit circle. Tan is always going to be the y-coordinate over the x-coordinate. And since tan is going to refer to y over x, we can very clearly see that the angle of pi over 3, the y over x would actually result in a radical 3. And the reason why is because y over x would be radical 3 over 2. All over 1/2. And if you went through the motions there, you would see very quickly that it would be radical 3. Now, it is the case that tangent functions, have a period of pi, not 2 pi, like sine and cosine have a period of 2 pi. Tan has a period of pi, so you can't just be like, u equals pi over 3 and then think that you've called it a day, because it's like tan of pi over 3 equals radical 3. You have to remember that it's going to be u equals pi over 3 plus pi times k. And this k represents an integer, okay? Because at the end of the day, the tan of what angles equals radical 3? Well, that would be pi over 3. That would also be 4 pi over 3. And then over here, it would be, what would that be? 7 pi over 3, and so on. And you would just keep going around forever. So that's why you need this k here to designate the fact that there are actually infinite solutions as to what u could be. When it comes to this problem, we're actually not done yet, because we had substituted u in. We know that that's 3 theta. So really it's the case that 3 theta equals pi over 3 plus pi k. And then we could divide both sides by 3 in order to get the answer. Now, when we divide both sides by 3, we're going to get theta equals pi over 9 plus pi over 3k. So that's how you do that one. Okay, so another problem would be the following. It would be sine squared theta equals 1 plus cosine theta. So at this point, the problem that we face already is the fact that you have two different trigonometric functions. You got sine and you got cosine. So it'd be nice if we could have one trigonometric function to work with as opposed to two. And my vote is to work with only cosines, because this could immediately be turned into 1 minus cosine squared theta equals 1 plus cosine theta. And the reason for that has to do with the Pythagorean identity. All right. So at this point, let's keep the cosines, the trigonometric functions on the left, and have like numbers on the right. So one thing I could do is I could subtract this one from both sides, and that would leave me with negative cosine squared theta equals cosine theta. And then from here, there might be a temptation to divide both sides by like a cosine or something, but that actually would result in a big old mess. You might want to actually subtract this cosine from the other side. And if you do that, you're going to end up with, well, let me just represent that. We might as well. So subtracting cosine theta from this side, subtracting cosine theta from this side. And what we end up with is negative cosine squared theta minus another cosine theta. And that equals, that would be 0. All right. Now, even though this looks like craziness, this is really just a quadratic situation. Before I even bother tackling it, um, well, actually, you know what? We're going to immediately use u-substitution right now. So we could call cosine theta our u. We could immediately move into u-substitution. So let's rewrite this as negative u squared minus u equals 0. Now, again, like I was saying before, this is a quadratic situation. If you want to solve quadratic equations, it's a good idea to have the first term be positive. So my thought is, why don't we divide both sides by a -1, and that would turn this first term into a positive term. So what would happen as a result of that is we would have u squared plus u equals 0. Now, in order to solve this quadratic equation, what we would have to do is factor out the GCF, which in this case is u, and you'd end up with u plus 1 equals 0. So at that point, we need to just keep in mind that whenever you're solving quadratic equations, it might benefit you to turn it into two separate equations from here on out, where we know for a fact that if u was 0, then 0 times whatever the heck this is would be 0. And we also know that if this parentheses thing was 0, then 0 times whatever the heck this is would be 0. So you could actually break that off into two separate equations, which I'm going to do right now. And those two separate equations would be u equals 0 because of the reasons that I said before, and then u plus 1 equals 0. Now, I could sort of proceed with this, but actually I want to work with this a little bit. Let's solve for u right now. If we solve for u, we're going to get u equals -1. I'm happy with this situation and this situation because now that we've solved for u, I'm ready to resubstitute this cosine theta back in to where it belongs. So basically we know for a fact that cosine theta is going to equal 0. And over here we know that cosine theta is going to equal -1. Now, looking here, cosine of what angle equals 0? Well, some of you might know that when it comes to the unit circle, the cosine function corresponds with x over r, also known as x over 1. So basically, we're looking for the x coordinates that feature a 0. So basically, the angles that are such that the x coordinate features a 0 would be pi over 2 and 3 pi over 2. So I would be comfortable with writing the answer, therefore, as pi over 2 plus pi k, where k is all real numbers. And why is that? Because pi over 2 plus, this revolution of, a half revolution of k. So pi over 2 would work, and then plus another pi would give you another angle that would work. Such that cosine of that angle equals 0, and then when you add another pi to it, well, that angle would work such that cosine of that angle would equal 0, and on and on and on. So this should suffice. So that's a theta, by the way, not a 0. All right, so the zeros always have this kind of upward diagonal thing. Then the question is, okay, the cosine of what angle equals -1? Well, that would be only pi. Only this angle would feature that x coordinate of -1. So only pi and the coterminal angles of pi, which means a full revolution of 2 pi around. So basically that one would be such that it's theta equals pi plus 2 pi k. So these are the answers to this problem. Okay, so another sort of equation that you might have to face in trigonometry is something like this, where it's like cosine of 2 theta plus sine squared theta equals 0.25. Now, let's just make a mental note right now that 0.25 is equal to, let me just fill that in. I know that's a little crazy looking, but if I leave that blank, it's going to drive me crazy. So 0.25 with this huge decimal. It's really 1/4, so just keep that in mind. All right. It's nice to know that we could sort of turn easy decimals like this into fractions if we had to. Now, one of the things that's important to realize is that what we have in our hands here is cosine of 2 theta. Now, at a certain point, you might be expected to memorize certain things, such as these like double angle formulas, like cosine of 2 theta. That actually equals 1 minus 2 sine squared theta. So that's something to just keep in mind. There's other things that this equals as well, but this is one of the things that cosine of 2 theta equals. And the reason I bring this one up is because it might be nice to replace this with that, because we already have this like sine squared thing going on right here. And it'd be nice to work with only one trigonometric function as opposed to two. So here we are about to work with only one trigonometric function by replacing this with 1 minus 2 sine squared theta. And we still have this plus sine squared theta over here equals 0.25. All right, so at this point, you need to be very careful. That's where like your algebra game has to be on point. You're going to be combining like terms. In this case, we have a negative 2 sine squared theta and a positive sine squared theta. So I'm going to rewrite that right now. The 1 just stays there for now. And it's going to be 1 minus sine squared theta equals 0.25. Okay, now let's commit to just keeping the trigonometric functions on the left. And what we're going to do, therefore, is we're going to subtract 1 from both sides. And what we end up with as a result is negative sine squared theta equals negative 0.75. Okay, at that point, I don't really like this negative that's in front of the sine squared theta. Remember, we're trying to solve for theta right now. So it'd be nice if we could at least get this negative out of the way. So I would suggest dividing both sides by negative 1 in order to get rid of it. I don't think we need this anymore. And as a result of that, we would have sine squared theta equals 0.75. And at that point, you can then take the square root of both sides. And don't forget to do plus minus right there. And then we end up with sine of theta equals plus minus the square root of 0.75. All right. Now, why did we go through all this? Well, number one, let's recap. We made it so that we only had to deal with one single trigonometric function instead of two different ones. So we converted this into 1 minus 2 sine squared. That was really the first step. Then it's this long process of getting it so that sine theta is completely by itself, because then and only then can you sort of refer to the unit circle and very clearly see what this angle is. Now, we have a problem though. This is 0.75. That's kind of an annoying thing to think about, radical 0.75. So what you might want to do there is actually rewrite it so that it's plus minus radical 3/4. All right, because at the end of the day, 0.75 is really equal to 3/4. All right, now when dealing with that, let's bring it over here. When you're going to have that plus minus radical 3/4, well, that's really the same thing as plus minus radical 3 over radical 4. And that's really, I'm just going to use equal signs, that's really the same as plus minus radical 3 over 2. So, you know what, I'll write this. I'll write the sign in there. So we have sine theta equals plus minus radical 3 over 2. Now, sine function, at least when you're kind of thinking about the unit circle, that corresponds with y over r. And since this is a unit circle, that corresponds with y over 1. So that means we're looking for y coordinates that are either positive radical 3 over 2 or negative radical 3 over 2. So clearly we have a y coordinate here, a positive radical 3 over 2. We have a y coordinate here, a positive radical 3 over 2. And we have a y coordinate here of negative radical 3 over 2. And a y coordinate here of negative radical 3 over 2. So that corresponds with pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now, it might be a little bit challenging to be like, all right, well, I know it's corresponding with pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, but how do I represent my final answer? Now, this is one that I might want to like break up into two separate answers that are both true. So, for example, we know for a fact that pi over 3 is one of the answers, right? And then if you kind of add pi to that, also known as a half revolution, you end up at 4 pi over 3. And then if you add pi to that, it's going to be to swing back here, and that would be an angle that would work. And then if you added another pi, it would swing back here, and that would be an angle that would work, and so on. So my first answer is going to correspond with this pi over 3 and the fact that we can add pi to it infinite times, and you'll get an answer that works. So the first answer that I would write down is that theta equals pi over 3 plus pi k. Okay, so it's like pi over 3 plus pi however many times you want. You'll just keep revolving around the circle. All right, and now I'm going to pay attention to the fact that 2 pi over 3 also has that radical 3 over 2 as our y coordinate, and then every time you add pi to that, you land at another angle that has, in this case, a negative radical 3 over 2 associated with the y coordinate. And again, keep in mind, that negative radical 3 over 2, well, that's one of the answers, right? It's positive radical 3 over 2 and negative radical 3 over 2. So I'm comfortable with calling the other answer such that theta equals 2 pi over 3 plus pi k also, because you'll keep on landing on an angle that gives you what you want. So, you know, you could also be like, I don't know, and if you want to get fancy, you could use like a union symbol as well, but let's just say and 2 pi over 3 plus pi over k. All right, so that's how you do this one. Okay, and another problem, this will be the last problem for this video, that you might have to deal with is something like, let's see, 3 sine squared theta minus 7 sine theta plus 2 equals 0. And right out the gate, hopefully by now you should be well trained enough to notice that this is a quadratic equation that should sort of look familiar. It kind of looks like the equations you had to deal with back in the day when you did like algebra 2 and you set it equal to 0, and you had to either use the quadratic formula or factor it or something like that. Now, it so happens that it's a little more complicated because we have sine in here. But anytime you see that it looks like something you used to do back in the day and you could solve easily or relatively easily back in the day, you might want to bust out the u-substitution. Now, in this case, the u would be sine theta. Now, for the record, whenever you're doing u-substitution where you have this trinomial and it's quadratic, you always want the u to be the middle variable, okay? Right there, all right? That's your u. So anyway, moving on. We're gonna rewrite this, therefore, as 3u squared minus 7u plus 2 equals 0. Now, we have this leading coefficient of 3, which sort of complicates things. We can't just like factor it like in a quick and easy way. We have to pull out some tricks of the trade. Well, first of all, we've got to ask ourselves, is this factorable? Because if it's not, we might have to use the quadratic formula. Now, I can tell already just by looking at it, and you could tell perhaps by looking at it or trial and error, that actually it is factorable. And the reason is because if you want to know if it's factorable, all you got to do really is multiply this number times this number, and you'll get what I think of as the magic number, which is 6, and then ask yourself, are there any factors of 6 that are such that when I combine them, I would get a -7? And actually, it's true. negative 1 times negative 6 would indeed give you a positive 6, and negative 1 plus a negative 6 would indeed give you a negative 7. So what that means is we can then take this thing and rewrite it. Now, different teachers will teach different strategies with regards to how to deal with factoring something like this when the leading coefficient is something other than 1. And what I would recommend is what I call the bomb method, and what's been called the bomb method. And that's where basically you rewrite this thing, and then you just go plus, no matter what. You just go plus, empty parentheses u, plus 2 equals 0. So the only difference here is what I did to this negative 7u term. I turned it into this plus empty parentheses u term. Now, what goes in here? Well, I'll tell you, what goes in here are the two factors of this magic number. That's what goes in here. And those two factors were negative 1 and negative 6. Now, why is that okay for me to just go from here to there? Because if we worked backwards, if we did negative 1 minus 6, well, that would be a negative 7u. Well, that's what we have up here. So that's why I call it the bomb method, is because we're taking this middle coefficient and we're exploding it into two component parts. It's like this is like a popcorn kernel in your microwave, and you apply the heat to it and it explodes it like that. Now, why the hell would we want to do that? The reason why we'd want to do that is because we're setting up a situation where we could do factoring by grouping. And the first thing we need to do is actually distribute this u here and there. Now, I know probably most of you are distributing something here, used to distributing something here or there, but you can also take something that's off to the right of the parentheses and distribute it in as well. And that's what we're going to do on the next line. So we end up with 3u squared plus, let's get this over with. It's not plus. It's going to be negative u minus 6u, all right, plus 2 equals 0. This in black is what we get after distributing this u here and there, okay? We end up getting this thing in black. Now, why would I want to do that? Well, now I can factor by grouping by focusing only on these two and focusing only on these two one at a time. Let's focus only on these two. I'm going to ask myself, what is the greatest common factor of these two? Well, that would be u. So I can factor that u out. I'm going to factor a u out, and I end up with 3u minus 1. Okay? I end up with 3u minus 1. And then I'm going to focus on these guys. I'm going to ask myself, what's the greatest common factor here? Well, that would be actually a negative 2. That would be a negative 2. And the reason why I want to do negative 2, let me just cut to the chase. The reason why I'm going to factor out a negative 2 here between these guys is because I need to force the next parentheses to match this. All right, so in fact, since I know that that's what I'm trying to do, I'm just going to write that. And then over here, I would factor out that negative 2. Okay? All right, so in case you're confused by that, just know that whenever you're factoring by grouping, we found the GCF of these guys and we factored it thusly. This parentheses definitely needs to match this parentheses over here, okay? And then, you could ask yourself, okay, what times 3u would give me negative 6u? Well, that would be a negative 2. Now, you could always double check and be like negative 2 times this, negative 2 times that, and you would indeed get this again, all right? So hopefully that's clear. Rewind it if it's not. And then it sets up a situation where you have this minus this equals 0. Now, factoring by grouping is such that you want to definitely treat this one, the parentheses that matches, that's definitely going to be in the near final analysis. But then there's going to be something else, some other shenanigans in parentheses. Well, what's this? Well, that is basically, what goes in here is everything that's left over up here, everything other than that 3u minus 1, which is going to be the u minus 2. So that's literally what goes in there. For my student who's watching, if you're not familiar with factoring by grouping, just go online, check out a couple examples of how to do it, maybe give yourself some practice. But anyway, here we have u minus 2 and 3u minus 1 equals 0. So similar to an earlier problem that we did before, we could separate this into two separate equations where we have this, and we also have this. This one right here, fairly straightforward. That's going to be u equals 2. And this other one right here, not as straightforward. This is going to be 3u equals 1. We would therefore have to divide both sides by 3, and you would end up with u equals 1/3. So let's not forget, of course, that, okay, u equals 2, but what does u also equal? U also equals sine theta. So basically what we've just discovered is that sine theta equals 2. And what we discovered over here is that sine theta equals 1/3. Now, when you look at this, you will come to discover that it's like the sine of what angle equals 2. Well, that would imply that on the unit circle, there would be some angle here that has like a y-coordinate of 2. And since it's a unit circle, there's no way in hell that's happening, okay? If you look at all the y-coordinates, they are anywhere between 1 and -1, okay? But not a single one of these goes up to 2. And that sort of makes sense also when you imagine the rectangular coordinates of the sine function, which looks like this. Well, what's the amplitude? You got 1 over here, and you got -1 over here. So there's no point where it goes up to 2, right? At least not with a regular old sine function, okay? So that's important to know. So this one doesn't represent any real solution. So we can actually ignore this one. Now, this other one does indeed have a solution, because if you think about it, the sine of some angle would correspond with a y-coordinate on the unit circle of 1/3. Now, if you notice, the y-coordinates here range from 0 to 1, so you know that there is some angle here, some angle, not one of these guys, but there's some angle in the first quadrant for sure that's going to correspond with a y-coordinate of 1/3. And I would also say that applies to quadrant 2 as well, because the y-coordinates here also range from 0 all the way up to this y-coordinate of 1. So there should be some angle here that is such that it corresponds with, you know, the y-coordinate of 1/3. So probably a good idea to focus on the first quadrant first. And what you could do is you could plug this into your calculator. So you could figure out the inverse sine of 1/3, and that's going to equal theta. And upon doing that, what you're going to get is theta equals 0.3398369. However, even though theta equals 0.3398369 according to the calculator, we're still trying to round this to 3 decimal places according to the directions. You can't see the directions, but I can. They want us to round it to 3 decimal places, so 0.3398369, blah, 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 that's going to end up being 0.34. So that is one of the angles, 0.34 radians, by the way. And by the way, if you're using your calculator, make sure that it's in radians. Most of the time, we're going to be measuring angles in radians rather than degrees, at least when we're referring to the unit circle. So anyway, yeah, you have 0.34, which means that you start at 0 radians, and then you go up 0.34 radians to a certain angle. And that would correspond with the y-coordinate of 1/3. So this is like 1/2, a y-coordinate of 1/2. So it would probably be like somewhere around here. Now, I think that that's a decent idea, or it's a decent idea to kind of draw it and really make a nice mental note. I know that looks kind of crazy, but I'm going to shrink it down in a second. But make a nice mental note that this right here is, well, we could draw it like this. This angle is 0.34 radians. All right, so that's something nice to know. And the reason why I am talking about that is because we know that one of our answers is going to be 0.34 radians and plus 2 pi k, because sine functions have a period of 2 pi. So one of the answers is most definitely going to be 0.34 radians and then a full revolution around every single time. Okay, that's going to be one of our answers. And I say we actually write that down right now. So I could actually replace this with 0.34 plus 2 pi k. So I'm happy with that. However, there is another angle over here that would also give us that y coordinate of 1/3. There's another angle over here, and I'll draw it, that would also give us a y coordinate of 1/3. And remember, when we're doing the sine, it's like sine of what angle equals 1/3. In other words, what angle corresponds with a y coordinate of 1/3? Okay. Now we already have the one over here. This would give us a y coordinate of 1/3, but there's another one over here that would give us a y coordinate of 1/3. Now how the heck are we going to find that? Well, probably the best way to find that one is to recognize that from this angle of 0, this flat line that is the x-axis here, we go up 0.34 radians to get to this angle. Where there's going to be symmetry over here, we're also going to go up 0.34 radians to get this angle. And in fact, I'm going to blow this up again, and we're going to write that. Going up 0.34 radians to get that one also. Okay. Now, we can't just call it 0.34 radians because we already wrote that down. The truth of the matter is we're looking for the angle that would go all the way from here and then stop there. Okay? So how the heck are we going to find the angle that goes all the way from here and stops there? Well, that's actually pretty easy. All you have to do is take pi radians and subtract away 0.34 radians, and then you'll have this angle left over. So you take pi radians as though you went all the way to this semicircle, and then you subtract away this little piece, this little 0.34 radians, and then you'll be left with this yellow thing. So I'm going to do that on my calculator right now. Okay, so that would give us 2.8. So that would be 2.8 radians. Now, similarly, since this is we're still dealing with a sine function with a period of 2 pi, it's still the case that, yes, this angle would work, but you know what else would work? The angle that you would get by going a full revolution around, that angle would work too. And another full revolution landing right here would also work, right? So we're going to want to represent that similarly to the last answer, where we're going to write plus 2 pi. Okay, so I would say if you're going to be thorough, you're going to want both of these answers. Now, some teachers don't care if you get the second answer. They only care if you get the first answer, okay? So if it's the case that you have a teacher that only cares if you get this first answer, namely, you know, you just plug it into your calculator, and then, you know, you plug your arc sine into the calculator, and then it pumps out 0.34, and then you can just kind of call it a day. Some teachers are happy with just going that far. So I'll kind of ask my student, if you know that your teacher would be happy with that, then just take it this far. If your teacher wants you to be super, super thorough, then you're going to need this other angle as well. All right, so that is all of the problems that were on the quiz. Hopefully this was helpful.